Hello everyone and welcome back to CodedByJade. In this video, I want to talk about what coding modules are like as a computer science university student. I'll be talking about the paradigms and languages learnt, the structure of the modules, and my opinion about how programming modules are taught at university. Before we get into the video, be sure to like this video and subscribe. Also, follow me on Instagram at CodedByJade, where you can DM me for personalized advice. I will also be reopening my personal statement reviews this summer to help you improve your university UCAS applications. Okay, so let's get into this video. What I learnt as an overview. This university year, as a fresher, I had 3 programming-based modules. These were called Imperative and Functional Programming, Object-Oriented Programming and Algorithms 1, and Software Tools. So the first two, being Imperative and Functional Programming and Object-Oriented Programming and Algorithms 1, were more like 2 10-credit units merged into one 20-credit module. Imperative, Functional and Object-Oriented Programming each had 3-hour labs per week, and Software Tools had 2-hour labs per week. So, as the titles of the modules describe, we learnt the Imperative, Functional and Object-Oriented Programming paradigms. For imperative programming, we were taught C at the standard 11, and for functional programming, we learned Haskell. And finally, in object-oriented programming, we were taught Java 11. Additionally, in the first half of Software Tools, we were basically given a well-rounded introduction to POSIX, where we learnt higher-level stuff like shell scripting and Linux system administration, as well as lower-level programming like interacting with inodes and pipes and the TTY. And in the second half of Software Tools, we were introduced to web programming, where we learned HTML, CSS, JavaScript, and React.js. Okay, so now that I've given a brief overview of each module, I'm going to go more in depth for each one about what we learnt, how this was assessed, and what I gained from that course. Let's start with imperative programming. As mentioned before, we learnt the imperative programming paradigm using the programming language C. And this course was basically an introduction about how to code generally, and we were first introduced to procedures, literals, constants, iteration, recursion, arrays, and basically anything to do with an introduction to coding. We then went into more depth about more low-level concepts, more applicable to C, such as manipulating bytes and pointers, as well as handling dynamic data. For this particular course, we were given 2 coursework assignments, one worth 20% of the entire module and the other being worth 30%. The structure of these assignments were that there were 2 parts, one known as the closed task, where the instructions of what needs to be done were clear, and if the code passed the tests, then a certain mark was guaranteed. The second part was known as the open task, where the instructions were more loosely defined, and the extra marks given were also more ambiguous. To achieve top marks, you had to go above and beyond what was taught in the lectures, as well as structuring your code well. So, what did I learn from this course? As I had already coded before in the past, I was already aware of basic programming principles. So what I gained most from this course was the more low-level concepts, such as the structure of programs running in userland memory. I've said this before in my video, why Python shouldn't be your first programming language, but I believe if you wanted to be a more well-rounded programmer, then you should start with a language like C or C++ to be aware of these more advanced concepts and truly appreciate how certain concepts help you achieve low runtime and memory usage in your programs. So next, I'm going to talk about functional programming. Functional programming is very different from the typical imperative or object-oriented programming that you may be used to. In this course, we learn basic functional programming concepts such as higher order functions, modeling data types, functors, monads, and applicatives, and how to program these in Haskell. And for this course in particular, I found it helpful to have the textbook which was known as Programming in Haskell by Hutton of the University of Nottingham. So, how were we assessed? For this course, we were given a winter multiple choice exam worth 50% of the module. We just tested if you understood concepts taught in the lectures with no extra trick questions. Overall, Haskell is more of an academic language, which I don't see myself using on a regular basis. However, the principles of functional programming that I learnt help sophisticate my programming style, allowing me to write cleaner, more readable code, such as utilizing higher order functions, such as map or filter, in other languages such as Python or Java, rather than lengthy for loops and self-written procedures. The final main programming paradigm that we learnt was object-oriented programming. And I would say that object-oriented programming was the most theory-based of the three, as I've already mentioned. Here, we learnt the principles of object-oriented programming, such as the structure of object-oriented programs in memory, types of polymorphism, and interfaces. We also learnt about different object-oriented design principles as solutions to coding problems, which was based on the book Design Patterns, Elements of Reusable Object-Oriented Software by the Gang of Four. For this course, we were given a paired programming coursework assignment worth 50% of the module, in which we implemented the functionality of a board game and then implemented an AI for the board game pieces to play autonomously. So, what did I learn from this course? This course strengthened my understanding of object-oriented programming, as I had previously learnt it with Python in sixth form. I was also introduced to lower-level programming concepts in this paradigm, such as interacting with bytecode and designing garbage collectors to optimize memory usage. So, a summary for these three paradigms. Our lecturer's mantra was that as university students, we shouldn't just learn how to code in a specific language, but be given an in-depth, theoretical introduction to the language and its associated programming paradigms. If this is something that you may be apprehensive about, for example, you just want to learn to code to be able to land yourself a career in the industry as soon as possible, then you may benefit from watching one of my earlier videos about university versus coding boot camps, and I'll leave a link to this in the information box. And finally, the module software tools, where we learnt about POSIX and web programming. Software tools was basically an introduction to computer science in the industry, where the main skills that we learnt were Linux system administration, SSH keys, how to use Git, and web programming. The structure of this course was to watch the lectures and then demonstrate what we'd learn in these lectures through small exercises during the labs. And this course was assessed using a summer online exam, which basically tested if we could apply what we had learnt in the lectures in different situations. So, let me give a summary of what I've learned across these modules in my course overall. Based on what I've seen and experienced on my course, although the programming modules I took did begin by teaching us how to code, the courses quickly escalated into more advanced topics in order for us to start the coursework assignments. And I think that the people that struggled the most were often people who had done little to no coding before starting university. I've mentioned this several times already, but I would say that if this describes you, then the best thing to do is to start learning how to code as soon as possible before starting university. And I've mentioned different languages you could start with many times, but you can also feel free to DM me on Instagram if you are curious about a certain language and you want to know whether it's worth learning. Okay, so this video was a brief introduction about how coding is taught at university, at least in my experience. Again, feel free to message me on Instagram for any coding related advice, and don't forget to like this video and subscribe. And my next video will be discussing how I study as a computer science student to get top grades. Thanks for watching this video. Bye.